Okay, guys, welcome to the third workshop for how to build a quadcopter. So the first week we went over frames and the basic components that you need for a frame, what you want to consider. Last week we went over ESCs, motors, and batteries, how those all relate to each other, what the different equations you need to find one based off another. And then this week we're going to go over flight controllers, specifically the flight control board, which on this quad will be this centerpiece right here. We don't really have many other examples today, but they're really what do all of the hard work. They do the heavy lifting, you can say. So this will be a two-part workshop. So this week we're going to go over part one. Next week we don't have the space, so we're going to take a break. And then the week 6, we're going to do the second part of this workshop, because flight controllers really are the most integral part of the system, and you really do need a good understanding of your flight controller when you're building a quad. We're going to cover today the common flight controllers that are on the market, from the low-end ones to the high-end ones, depending on how much you want to spend. We're going to cover the specs of the low-end ones, because those are really what we're going to be focusing on for the 250 class racing quads. Next week, or 2 weeks from now, we're going to be going into the firmware, and we're also going to be talking about the application integration of these flight controllers. So what is out there? You can go from flight controllers that are as cheap as $15, $20. You can get flight controllers up to the high end, like the one on that is $260. So you really have a choice, and what you pay for is kind of how much you get. The Pixhawk really makes the quadcopter a robotic quadcopter. It gives you autonomy. You can click a button and it'll do what you say for it to do. The low-end quadcopter flight controllers, like the OpenPilot CC3D, the NACE 32, those are really give you RC control, and that's kind of the extent of it. The ones in the middle, kind of the multi-Wii, the APM 2.6, those give you the ability to maybe do autonomy, do your own firmware integrations, but it's not off the shelf. You're not paying for the engineering that's gone behind that. You really have to do the work to really unlock everything. So those are the middle of the road. They're usually open source, but they do require a lot more knowledge to unlock all of their secrets, I guess. So we're going to be sending you guys these slides as usual, and when you're looking for flight controllers, this is a good basic comparison chart, I'd say. You can go on this, you can say, what price do I want? And you can look at the price ranges that you want. And then there's going to be the modes, the PPM, which is, what does that PPM stand for?
I don't actually.
Okay, it's something pulse modulation. And then PWM is pulse width modulation. And that's how the receiver sends the signal to the flight controller. Then barometer, compass, GPS, those are what is included, not included, what you can attach externally. And then finally the microcontroller is what you get on board the actual flight controller itself. So this will be sending out to you when you're looking for your flight controller. This is a good starting point to go to, and make sure that what you're getting has what you want. So for the 250 class racing quads that we're going to be going, really what you need is RC control. We're going to be looking to eventually have you guys work in competition to, race around, and you're not going to be really going for autonomy purposes, competition-based quadcopters. As you're going for a cheaper kind of system, you're going to probably want to go for the NACE 32 or CC3D. A lot of Levi's quads that he designs use those flight controllers. They're cheaper and they do a lot of things. They really are user-friendly. And what these flight controllers kind of give you, they give you flight stabilization. They cost not that much. $25 is not a lot for something that gives you the ability to fly a quadcopter. They do have limited GPS ability, and you can also attach external barometers, compasses, but Levi's going to talk about that more in depth as the slides go on. So, you want to talk about these?
So you said, yeah, next we're going to go over just the basic components of the flight controller itself. And this slide, we're just covering the main three things that all of them have. If you're not familiar with the flight controller itself, what it is basically, it's just a microcontroller itself. Just it's got a processor on it. You can put coding and program it. And the difference with flight controllers from any other microcontroller is that they have a built-in accelerometer, 3-axis gyro, and the barometer. Just real quickly go over the difference in those. The accelerometer, as you could probably guess easily, is acceleration forces, measures back and forth, forward, backwards, and up and down. Then the gyro, level on all the different axes. Barometer can actually very accurately test air pressure, so you can tell when it's going up or down to control stabilization. And all those three combined, you get your basic of the flight controller. I include these pictures just to make an example of it, because that's an actual flight controller, like the, I think that's the NACE32, but this is just an Arduino, just to show that you can actually, do any microcontroller, and I think that's a barometer, and then the gyro itself separate, so. More advanced components. These are the more spendy stuff. This is when you're getting into the $200 range and like the bigger quads. But power module basically regulates your power supply and tells you when your voltage is dying out. You can also attach that to like an on-screen display. Let's see, GPS and compass. Obviously, yeah, receives coordinates for location of the craft. If you want to do waypoints or return to home, any of those features, and compass just adds on to the basic of the last ones and controls your spin as far as yaw.
So on this quad X8, this is the GPS module. It's an external GPS. It's not built in. You mount it high, so you get best satellite feed. You don't get away from all the magnetism that the currents running through all of the ESC wires, all of the extra wires go. So that's typically GPS setup, and that's the physical GPS on it.
And telemetry, I don't think we don't have one of those on there, do we? Oh, we do.
Yeah.
Okay. Telemetry basically just another wireless receiver transmitter that can connect your computer, so you can actually control the waypoints as you're going.
Yeah. So this is the telemetry module on this. Usually you'll have a software on your computer that you'll interface with the quadcopter, and having telemetry allows you to talk to the quadcopter from your computer rather than having to connect via like micro USB or something. So it's really useful, as Levi was saying, for updating waypoints if you're going that route.
And last thing, I didn't spell it out there, but OSD on-screen display. Basically just a chip. I don't know if I actually have a picture of. Okay, yeah, there's one. Just takes all your data, location, altitude, all that, and then it puts into a display so that you can combine it with your FPV. So, last thing I want to say before we move on to the next slide is they mentioned limited GPS. If you're wondering what that means, that actually just means that it receives the location, but you can't control it. So like if you had an on-screen display, it would show you your location and all that, but you wouldn't be able to do anything as far as waypoints. And assembly. And this is just an example of a multi-Wii, basically all the same, but over here you got your basic, your motors and everything. It's not really showing up that great on the screen, but one thing I want to show is that you only really need one wire for each signal going to your receiver. Otherwise, if you can see up here, barely really, you got your white for the signal and then the red and the black. You only need one for the voltage supply, and that's powering the whole flight controller itself.
Yeah, so as you can see, you have your red voltage, black ground, and you have your 5 wires, which will be your throttle, yaw, pitch, roll, and then your 5th channel, which will go into your receiver.
And yeah, signal's always a little bit of guess, and I guess you can probably see a little plus or minus, but last thing I'll say before we move on is if you're ever wondering, like, where to put the positive if you don't have an example already. The positive is always in the middle. I have burnout receivers that way by putting it in the ground or the signal, so just positive in the middle always.
That I stress this very loudly and clearly that the positive is always in the middle. We had a receiver on this one and we burned it out, so right now we don't have a working receiver well, we had two, so we now have one. But literally a week ago we burned it out because someone put the positive in the negative and fried it. So that's very important if you don't want to throw money out the door. That was just very, very basics of flight controllers, the very basics of what they do. Later we're going to go into the firmware and software on the computer, what you're going to see through that, and everything else you really need to know about your flight controller. But one thing we didn't cover last week on ESCs and motors is how to calibrate an ESC and its respective motor. So Levi's going to go through that today and show you the specific steps of doing that. So, do you want me to put this forward so you don't have light in your eyes?
Okay, so basically to explain what we're doing real quick is we're setting up the speed controller. We're telling it where the endpoints for the like low and high throttle is as far as calibrating this. What we're doing. Let's see, first steps. First thing we want to do, plug in the ESCs.
So do you only have to do this for an ESC or do you have to do this for an ESC motor combo?
No, I don't think you have to do it with the motor, just the ESC. So.
Okay.
Oh, wait. Yeah, the combo, sorry.
Okay.
First step, power on, flight controller. I'm trying to remember steps as we go. So. Basically calibrate, you want to put it at full throttle, and that's how we're going to tell the ESC when we turn it on that we're calibrating it.
So when you power on the ESC, it's going to be looking for either nothing, no throttle, or it'll be looking for high throttle, meaning it's going to go into calibration mode.
So generally, we haven't covered receivers yet. Traditionally, the throttle's on 3, so.
And so for this step, you don't need a flight controller or any other hardware, just
just the
ESC and the
receiver
motor.
itself, yeah.
So you need the receiver that's going to
Right.
get from the signal from the transmitter, and then you need the motor ESC combo.
So first thing first, I'm going to plug in the receiver. I already checked to make sure I have positive and negative.
Yeah, and if you don't do this, you may get very weird things from your ESCs. You may get very weird flight inputs when you throw on the throttle. It might just not work. So it's fairly necessary.
So when we plug it in, it's going to make a ring and let us know. And so basically we drop it down to low throttle. Makes another ring, and that's telling us that it's calibrated. It found the high and low endpoint. That's simple. So.
Yeah. So that's just basic calibration of ESCs. It's very easy, but it can get, when you're going through all of these steps, it could get a little overwhelming, and you might forget to do this step. But as you see, it's very easy. You just plug it. You go through the steps. We didn't put together the step 1, 2, 3 steps on this, but we'll put those in the knowledge base so you guys have something to look back on when you probably forget this in like 5 weeks or something, because I'll forget it in 5 weeks. Yeah.
By the way, you just mentioned knowledge base. How do you get to the knowledge base?
I'll send out a link for that in the after email. Does that sound good? Sweet. Any questions at all? You guys have?
Should I show them why you always want to plug the battery first?
Sure.
See what that happens. So, yeah, I don't know, I've had that happen before, and I just take off, so. Always unplug the battery, and then the receiver kind of thing.
Yeah, so, yeah, we're going to be trying to give you tips and tricks on the specific things to do and not to have your quadcopter fly away and you don't have a battery, or you do have a battery. Anything? Questions? All right, sweet. Thank you for coming. There was a short one this time, but next 2 weeks, then we'll go more in depth into flight controllers. If you want to stick around, we'll have Carl's little mini quad that you can fly. And yeah, if you have any questions, thanks for coming, guys. It sounds so good. Wait, it spins.
This one,
Sounds like a TIE fighter almost.